Hyperbolas will look like either this, sideways facing, or up and down facing in our class. We have diagonal ones and stuff, but these are going to be the ones that we're going to talk about in here. Okay. So let's talk about the pieces. Darn it. I thought I could move that without having to move too much stuff, but I think I will need to. All right. You know what? That was not beautiful. I can just erase it. All right. So let's talk about the pieces. The first pieces are like, duh. You guys already know this. These are going to be called vertices. They're a vertex. It's like if you could have guessed what that's called, you would have called it a vertex. So that's nothing new, just like on a parabola, right? That's where the vertex is. All right. Then the focus will lie inside each one of these little parabolas, if you will. That's where the focus, or the foci, if you're going plural, where the foci will be. All right. And then, of course, this is what we're going to call the center. The letters that you're used to still apply. So all that hard work you did with the ellipses still holds true. The distance from the center to a vertex is still going to be called A. The distance from the foci and the center is still going to be called C. So nothing has changed in that regard. C is bigger than A now. So that's interesting because C used to be smaller than A when you were in an ellipse. But that's it. Now looking at these formulas, some things that are different. Let's just highlight the differences. This is different. That wasn't the case with an ellipse, right? It was a plus. So that's new. Okay. What else is new is that Y can be in the front sometimes. That's new. So A squared, you guys, has nothing to do with who's bigger. A squared will always be the first. Okay. So A squared is no longer the biggest. It's whoever's first. All right. Some other things that are different. This guy. So we truly have the Pythagorean now, right? So for the test, how I memorize it is I go, hey, whatever's here, that's the opposite. So if this is a minus sign, that's a plus. If this is a plus, then that's a minus. It's just always going to be opposites. Okay, I think we covered all of the big differences. Now, if Y is first, then on your asymptote formula, A will be on top of B. If X is first, B will be on top of A. Okay. All right. I kind of, to help me memorize that, just say yabba dabba do. So I think Y, if Y is first, it's A over B. That's how I get the yab from yabba dabba do. Y is A over B. Okay, so X must be B over A. But you guys have note cards, so I don't know if that's super important, but yabba dabba do is what I used to think about. Is that, I know some of you know that, but for you young people, do you even know what that is, yabba dabba do?
Oh no.
Yes, Oscar, you, I don't know, how old are you? Would you consider yourself, are you in your early 20s? No, well, right? Okay.
But I'm 22.
Okay. All right. Okay, cool. So some of you do know it is from the Flintstones. Yeah. Okay. I wasn't sure if that was still a thing or not. All right. When I first started teaching at Sultana, I had this icebreakers game where famous couples were on the cards. So like I had, one of them was Courtney Love and the other one was Kurt Cobain. And you had to like ask each other questions to try and figure out who was your famous couple spouse. And like none of the kids knew who Courtney Love was. And I was like, oh my gosh, I'm that old now that my students don't know the stuff that like I grew up with, you know. Anyhow, Nirvana's made its comeback, so maybe people know now, but All right, let's see here. So this is just kind of showing you that if it's a plus sign, you're going to have an ellipse, right? But if you have minus signs, you're going to have hyperbolas. Now, if x is first, it's exactly what you would think. It's going sideways in the x direction. If the y is first, then it's going to go in the y direction, so up and down. Okay, it's the same exact box that's drawn. The box hasn't changed at all, right? And that makes sense because the 4 is under the y, you know, the 4 is under the y, the 9's under the x, the 9's under the x. So the box doesn't change. Just by putting y first, it just changes where I'm going to draw my hyperbola. Okay, so let's go in here and try some. Okay, graph the hyperbola. So identify the center, the vertices, blah, blah, blah. Okay, so the first thing that we're noticing is that since there is nothing with the x and nothing with the y, then the center is just going to be 0, 0. So let's go over there. I'm going to put a dot. Okay. Now we said a squared is no longer who's biggest. A squared is whoever's first. So that means a is going to be 4. Since it's underneath y, you're going to go 4 in the y direction. 1, 2, 3, 4. 1, 2, 3, 4. Similarly, b squared is 20. So b is root 20. That's 4 times 5, you guys. So that's going to be 2 root 5. And that's under x. So if I put square root of 20 in my calculator, it's telling me 4.7-ish. I mean 4.47. So I'm going to go 4 in the x direction. 1, 2, 3, 4.7, 47, sorry. So like right there. And then 1, 2, 3, 4.47. So not quite 4.5, 4.47. So less than halfway, but barely. And now what's new is I'm not going to draw an ellipse. This isn't an ellipse we're graphing. We're going to draw a box. Okay. So the box that you're going to draw, I wonder if, no, it doesn't let you do that. The box that you're going to draw is only here to guide your graph. It's technically not part of the graph, you guys. It's just there to guide it. You'll see what I mean in a second. Oh, geez. I wonder it wasn't selecting. Okay, so once you draw the box that goes through those 4 points, you're going to draw a box that connects corner to corner. So I'm going to try to make it, there we go, corner to corner, and you'll see where this is going in a sec. There we go. All right, now the reason we need those, okay, why do we need that? Well, since the y is first, you guys, which way does this open up? Does it open up horizontally or vertically? Y is first. So does it open up horizontally, aka left and right, or does it open up vertically, aka up and down?
Is it vertical?
Mm-hmm. Since y is first, it opens vertically. Okay, so we know that it's going to be something like, something like this. You know, but without those lines, how do I know if it's like that? How do I know if it's like that? How do I know? You know what I mean? Those lines are going to tell me how wide to make it. So I now know that I have to hug tight to those lines. There you go. So they're there to guide how wide your hyperbola should be. Okay. So as far as graphing the parabola, we did it. So let's go in there and get the center. We did that. So let's get the vertices. Now there's two ways to get it. I'll show you both. If it's easy like this and you've graphed it, you know, bring graph paper to the final exam, then just count. Don't get all crazy and mathy with it. Just go, well, where is this dot at? You know, it looks like it's at 0, 4. Okay, there's one of them. And then this one down here looks like it's at 0, -4. So if you have a graph, don't do what I'm about to do. I suggest you look at the picture, okay? But let's say you don't have a graph, somebody just gives you the equation and you don't have graph paper, you don't trust your own drawings, you know? Okay, then your formula is very much like with an ellipse. Since it opens up in the y direction, you're gonna add and subtract the a to the y value. So we're gonna take our center, which was 0, 0, and we're going to add and subtract a, which is 4, to the y value. So we have 0 and plus or minus 4. And what do you know? It matches what we got from the picture. Okay. For the foci, it's exactly like it was for an ellipse. Same thing. You're going to add it and subtract it to the y value because it has to match the vertices. But this time it's the letter C. Okay. So we have 0, 0 as the HK, but we currently are missing the C. Well, I think we know what formula is going to help us find C. What do you guys think? Oops.
Yabba dabba doo. No, I'm just kidding.
Yeah. Well, it's got, so I'll give you a hint. Okay, no, never mind. Melanie gave us a big hint. She gave it to us completely. Yeah. A squared plus B squared equals C squared. Remember, if it's a minus here, that means it's a plus here. Okay. And we know A and B. So we just, A squared and B squared. So we just got to plug them in. So we got 16 plus 20. So 36 equals C squared. So C must be 6 after you square root both sides. So you're going to put a 6 in there. Bam. Okay. And so you end up getting 0 plus or minus 6. Again, you don't have to use that formula. If you find out that C equals 6, right? Then just count 6 up. 1, 2, 3, 4, 5, 6 and put your X. And count 6 down and put your X. And you always should have your foci inside the parabola. So that looks great. That looks like those are the right spots. All right. Then get the equations for the asymptotes. So John is right. Since y is first, it is going to be yabba dabba doo. Okay. So since y is first, dare I spell that? Yabba dabba doo. All right, I'm going with it. The key part being this part though, right? Y first means A over B, okay? So we're gonna put the A over the B. So it's going to be, what was A again? 4. And then B was 2 root 5. And then they'll probably want you to, you know, reduce the 4 over 2. So if we reduce the 4 over 2, now in the study-a-thon, I noticed this came up of rationalizing the denominator. It hasn't come up a lot in our class, but let's just rationalize the denominator really quickly so you guys get good at that skill in case it's on the final, okay? Like it's on the final review. So if you want to get rid of the radical in the bottom, do you guys remember what you need to multiply by to make that radical go away?
Another radical.
Yes. So you're going to just copy the radical in the bottom. So when you do that, you get 2 root 5 and a root times itself. Well, think about it. That means it's squared. That should cancel then, and you should just get 5 out. Okay, or you can actually do the math. Root 5 times root 5 is root 25. Well, if you square root to 25, it's 5. So Connect Math might not like that there's a radical in the denominator, So if you see that it's not liking that answer, then just go in there, rationalize the denominator, and maybe try plugging this in and see if it likes that better. Okay, both are fine for me. But if you have a multiple choice test, you kind of got to know, right? Like what happens when you look at the answers and you're like, dude, it doesn't match mine. Okay. Yeah, so this is us doing it completely formula based. Let's say that you forgot the formula, you didn't put it on your formula sheet. Well, in some cases like this, you can just do y equals mx plus b, you guys. This is an easy enough case where, you know, that would be pretty simple. For example, if I'm looking at this green line right here, right? Well, what looks like it's going to be the b? What looks like it's going to be the y-intercept, you guys? Perfect. Yeah, it crosses at 0. Okay. So in the y equals mx plus b, we have the b to be 0. Then you can just straight up count the rise over the run. We went up 1, 2, 3, 4. Okay, so 4 is the top. Then we went over 1, 2, 3, 4 and some change. Oh yeah, that 4 and some change came from 2 root 5. So then you can just put the 2 root 5 in and just make sure it's negative because it slants towards the left. So you can do that. You can still use y equals mx plus b on a simple problem like this where it goes through the origin. Okay. So that'll work too. You'll notice I only did the one line. You know, it has a plus or minus in front of these. Well, and that's because one line slants towards the left and the other line slants towards the right. They have the same exact slope, just one will be positive and one will be negative because they're slanting different directions. So that's why you'll always have that plus or minus there, you guys. And you can see, yeah, A over B makes sense because A was 4 and it was the B that was the root 20 or 2 root 5, whatever. So A over B makes sense. So if you want to go y equals mx plus b with it, by all means do. If you want to have this formula written on your note card, I'm fine with that too. Okay. So these formulas would actually be the ones I'd write on my note card because these cover all hyperbolas, whether or not they're centered at 0, 0. Those last formulas, you guys, were just centered at the origin. These are more powerful because you'll notice I have an h and a k now. And look how much more complicated it makes the asymptotes, right? So definitely write these down on your note card for the final. Okay, it'll be helpful. All right, let's go in here and do these. I think most of it will be pretty simple for you guys. For example, let me ask you this. What do you think the center is? I haven't taught you, but what do you think it is? Very good. Change the signs on those things. Yep. Okay. So we're going to go to 4, -3, and we're going to put a dot. All right. That's going to be our center. Okay. Who's a squared, you guys? Good. 9. Not because he's bigger, but because he's first. So that's going to make a 3. And keep in mind that's under x. So we're going to go 3 in the x direction. Then b squared must be the other one. So square root of 7 is how far we'll go in the y direction. Square root of 7, according to my calculator, 2.6-ish. So we're going to go that in the y direction. So I'm going to go 1, 2.6, so a little bit more than halfway. And then 1, 2.6. And don't draw an ellipse, draw a box. So here's our box. You know what, it might just be easier for me to just do it by hand. There we go. All right, so I'm going to draw diagonals. There we go. Okay, I guess the next thing we got to figure out is which way we're facing, huh? So is this going to face horizontally or vertically? Or up and down or left and right, whatever. Since X is first, it opens.
What, like left and right? Is it when-
Yeah, perfect. Left and right, horizontally. Whatever language there. Horizontally. All right. So we know how to draw it now, you guys. So here we go. Perfect. Okay, so the graph part, we're done. And we even have the vertices just from the graph. It looks like it's going to be 1, -1, 2, 3. And it looks like it's going to be 1, 2, 3, 4, 5, 6, 7, -3. That's me just not even using any formulas, but just saying, hey, that's a vertex and that's a vertex, right? If you want to use the formula, you know that it's H. Now, because it's sideways, everything needs to be done to the X this time. So if we take the H and K that you guys gave me up here in pink, right? The H is 4, the K is -3, and then A is 3. So we're going to be adding or subtracting 3 to that. So if you just kind of do it in your head, 4 plus 3 is 7. 4 minus 3 is 1. So that's if you like the formulas. Let's say you're in a situation where you don't have a graph. Okay. All right, foci, same deal. They lie in the X direction too. So it seems like we should do it to the X. The only problem is we don't have C. So we're gonna go in, use our favorite formula. It's come up a lot this class. And we'll plug in the A squared. We'll plug in the B squared. After you square root both sides, 4. All right, so we're going to put a 4 in there. Again, let's just do it in our heads. So 4 plus 4 is 8. 4 minus 4 is 0. Let's see if it worked, you guys. So logically, if C is 4, then we should be going from the center 1, 2, 3, 4 spaces. And 1, 2, 3, 4 spaces. We should be right there. And if you look at these ordered pairs, that's the 0, -3. So we did a good job there. And then this is the 8, -3. Okay. All right, asymptote time. So this is the more complex formula. It's not yabba dabba do because X is first. So it is going to be B over A, not A over B. Again, as far as using y equals mx plus b, it'd be hard on this because if you guys look, it kind of looks like it goes through no man's land. Like if you said, hey, what's the y-intercept? You'd be like, 0.5, 0.6. I have no idea where that crosses, right? And so you're kind of like forced to use the formula, okay? So let's go ahead and plug in the h and the k. So h is 4, k is -3. B is √7. A is 3. And you have your two equations. Okay, you box them. Bam. Okay. All right. If you've done your 7-1 homework, then you should kind of feel like, man, this is very similar. I'm just adding this whole asymptotes deal and maybe drawing things differently, but this feels familiar right in here. Like you're like, I've done that before, okay? And this feels familiar right here too. So it's kind of building on itself, which is nice. Do you guys have any questions on this slide? Okay, I don't know if that's sheer terror or if that's like, we get it. Hopefully we get it. Okay. So this one says, write the equation of the hyperbola in standard form. Well, you guys know how to do this, okay? I'm not really adding anything except for the very end has a little twist on it. The rest of it you're good with. So we're gonna group X's together. We're gonna group Y's together. Anybody else, shoot them over to the other side. Now don't complete the square yet. You got to factor out the leading coefficient before you complete the square. Remember, factoring out means dividing. So just think of it as dividing, you guys. So it's going to be x squared plus 10x. On the next one, we're factoring out 5. Remember, you're just dividing by 5 then. So think, what is 80 divided by 5? No, really, guys, what is 80? What is 80 divided by 5? 16? Is that right?
Yes.
Okay, cool. All right, then complete the square. So we're gonna do half of b squared. We're gonna take half of 10, which is 5. Square that guy, boom, 25. But don't put plus 25, right? Nobody's gonna do that. I'm sure a lot of you were, and you're like, what? This -4 has to multiply by the 25 to get you -100. That's what you're putting over here. Let's try it again for this one. So we have to take half of 16 this time and square them. So 8 squared, 64, but not really, right? 5 times 64. So 320. Okay, guys, tell me what goes in the parentheses. So in other words, factor those polynomials for me. So the x squared plus 10x plus 25? What's that?
X plus 5.
X plus 5, nice. The y squared minus 16y plus 64?
Y minus 8.
Good. We're literally just halving the middle number, halving the middle number. Hey, half of 10, boom, that's 5. Hey, half of -6, oh, that's the -16, that's -8, okay. All right, these guys make -300, so 20, it looks like. Now, we've already done this too. We can't have a 20 over there. It's supposed to be a 1 in the formula. Oh, divide them out. Divide them out. Now, just divide here, right? So 4 goes into 20, so it's going to be -5 down here. 5 goes into 20 4 times. Now, here's the thing, you guys. This is not how the equations look. The equations for a hyperbola have a minus in the middle. They don't have a plus right here. That's not what it looks like, right? So this -5, shove that -5. Whoa. Let me try this again. That negative sign that was with the 5, pull them off to the side, and then just pull a whole switcheroo right here, right? Like flip these guys around, and then you'll have it in the form for a hyperbola, where you have the minus in between. the two. So that's what I meant by the ending has a little twist on it. That's new. We've never done that. But the rest of it, you guys have totally done. Okay, so hopefully the rest of it doesn't feel that bad. Okay, write the equation in standard form. Done. Questions on this, you guys? If I'm highlighting hard parts, it's these guys right here. The 100 and the 320. That's something people forget. And then if I can highlight another weird part, it's just flipping at the end, knowing to do that. So those are the hang-ups whenever I watch students do these types of problems. Okay.
You said flipping them at the end. Well, I'm sorry, I don't quite get that.
Yeah, so the formula for an hyperbola has a positive term, then a minus sign in between them, and then another term. It's never like this, where it's like a minus here and a plus there. They just don't write it like that. So if you ever see that you have that situation, like, instead of writing -2 plus 7, you can write that as 7 minus 2. You can like flip flop, the order that those come in. And so that's what you're going to need to do if the negative term is first, because you always want that minus sign to be in the middle. So that's what we did on this one. We said, oops, the minus sign's in the front. It's not supposed to be there. It's supposed to be in the middle. Oh, okay. Let me switch them. And now the minus sign is in the middle. Does that kind of make sense?
Yeah, okay, yeah, totally got it. Thank you.
You're welcome. So it says, determine the standard form equation of a hyperbola with those vertices. I always draw it. I just have to. I'm going to draw it and I'm going to stare at it. Okay. So if I have vertices at 3, 0, so right here, and at -3, 0, the sheer fact that those are vertices, remember the vertex will always be like that, right? Okay. That tells me which way this is facing. Is this hyperbola opening up and down vertically, or is this hyperbola opening left and right horizontally?
Horizontally?
You bet. Okay, so from where the vertices are placed, we can tell that it is opening left and right horizontally. Okay, and that's important. That's enough to tell us X is first. So that tells me a lot. It tells me which formula I'm going to write down. That was big. I claim it also gives us one of our letters. Which letter does it give us, you guys?
A.
Yeah, it gives us A. The distance from the center to a vertex is always going to be your A. Okay. So we know that A equals 3. So let's see here. Hey, in the process, I just gave away what the center is, right? So what's the center for this?
0.
0. So I think we know quite a bit. It's just an x squared. It's just a y squared. And we know A is 3, so this has to be 9. Okay, we're not doing too bad. All we're missing is the b squared. So let's use this other fact, okay? So since x is first, we know the formula for the asymptotes is not yabba dabba doo, okay? No plus or minus thing. So it's not going to be yab, so it's not going to be A over B, it's going to be B over A. Okay. All right. So that's a big deal because if you look at what they have for the asymptotes, there's a root 3 here where the b over a is. So you can literally set those things equal to each other. And then we know a is 3. So we can just put a 3 where the a is and solve that. Okay, so what would you guys do to solve that?
What do you mean? B thirds over the square root of 3?
How do I get b?
Well, you're going to multiply by 3.
Good job. Okay, so now we know what b is. B is 3 root 3. To put it back into the formula, we have to square it though. We don't want b, we want b squared. So if you square that, you got to square, I kind of ran out of space here, huh? You got to square the 3, which will get you 9, and you've got to square the square root, which will make the square root go away. So b squared is 27. So we are done. Picture is key. I don't know how you would get this done really without kind of a picture to guide your thoughts. I guess you could on one that's centered at 0, 0. It's really hard when your center is not 0, 0 anymore to do that. Dun, dun, dun. There it is. Okay. So the eccentricity formula is exactly the same. It's c over a. Okay. So the same for an ellipse and a hyperbola. But notice since in a hyperbola, A goes from the center to a vertex, while C goes from the center to a focus, C is bigger than A now. So if C is bigger than A, then that means that you'll have a number bigger than 1. Okay, remember if the top of a fraction is bigger than the bottom, then the number is bigger than 1. Okay, so that's what they're saying here. The eccentricity is now going to be greater than 1. Those questions that you guys asked from 7-1, recall for an ellipse, it was in between 0 and 1. So this is new that it's bigger than 1. And why we care about it is it tells us, same thing, you know, how eccentricity tells you how nearly circular you are, kind of like how to draw your ellipse. This tells us how to draw our hyperbola. So as the eccentricity grows, the hyperbola becomes wider and wider. So, you know, if you have a small eccentricity, if you have a big eccentricity, right, you're going to have those two different types. Now they kind of try to illustrate it here a little bit. So this one's definitely narrower than this one, okay? And so let's go in and get the eccentricities for both. Oops. So the eccentricity is C over A. The eccentricity is C over A. Okay, so from what we're given, A squared is always the first number. So A squared is 15. So we know A is root 15. So as far as the formula is concerned, you guys, we got the bottom. Okay, B squared is the second number, the 2. So if we do A squared, since it's a minus sign, plus B squared, we should be able to get C, okay? So we're gonna plug in the A squared, we're gonna plug in the B squared, square root both sides, C equals root 17. So we're gonna go ahead and put root 17 up here. And it may or may not accept that. It might want you to do what we did earlier, rationalize the denominator. Gosh, 105? Oh no, that's 17. I only saw the 7. Lefty issues. Okay, so 17 times 15. 255, sorry you guys, 255 over 15 would be like a cleaned up answer for it. Now, we want to know about how big that is, just so we can kind of, looking at how skinny those are, it's got to be pretty close to 1. Okay, yeah, it's approximately 1.06. So that's really close to 1. So that explains why we have skinny branches. Close to 1, so skinny. Okay. All right, let's compare and contrast that with this one, okay? So a squared is going to be the first number. B squared is the second. So we know a is 5. So we have that part of our formula. All right, now let's use a squared plus b squared equals c squared. So we got 25 for the A, 24 for the B. Ooh, that's a nice number. So we can square root that pretty easily. So C equals 7. So if you divide that out, that's definitely bigger than the last one. It's 1.4. So it's bigger than 1.6, okay? So it's going to be wider than the last one. Okay, this is the answer we want for the eccentricity. The last part is just us comparing. Oh, okay, 1.4 is bigger than 1.06, so we should expect wider branches. All right. Any questions on that, you guys? Okay, moving right along. Give the equation of the hyperbola in standard form with vertices, blah, 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 and eccentricity, blah, blah, blah. Okay, again, I need a picture, guys. So I'm going to try to graph that. Okay, so we're just going to pretend this is -4. And we're going to say this is 1 and this is 13. I just need them to guide my thoughts so I don't have to be all super specific and stuff. Okay, what are those? Those are the vertices. Okay, since those are the vertices, it's got to be one of these guys. Since those are the vertices, it's got to face up and down, right? Let's see, 36. And we know the center. I'm going to move this over here. Okay. We know it faces up and down, and we know the center. So let's think about what we know. Since it faces up and down, y has to be first. Okay, we know the center is like, I don't know, like there-ish. And you guys already told me how to find the middle of two numbers. I can't remember what we were doing, but you guys said average it, right? So if we want to find out what's in the middle of 1 and 13, just add them together and divide by 2. So apparently 7's in the middle. Let me double check. Those are 6 away from each other. Yep, and those are 6 away from each other. Okay, this is looking pretty good. So that places the center at -4, 7. All right, things are coming together, you guys. So we know, now just don't have a dyslexic moment. It's so tempting to put y plus 4, but the y value is 7, you guys. So put the 7 with the y and put the plus 4 with the x. Yeah, you still change signs when you put them in, but just make sure that you put x with x and you put y with y, right? This is x, this is y, or h and k, whatever. Okay. All right. So now I claim, now that we know where the center is, I claim we know A. A is the distance from the center to a vertex. That is A, right? That's 6. We know A equals 6. So we're just going to go ahead and put a 36 here. And now I have no idea. Let's see. I don't think we can get anything else from the picture. Okay. All right, so we got nothing else from the picture. Let's use the eccentricity now. Okay, so eccentricity formula is E equals C over A. And we know the eccentricity is 5/3 from the directions. And we also know A. A is 6, so we're gonna plug 6 in. And then, well, you guys know the drill. If you wanna get C by itself, multiply both sides by a 6 to cancel it. And let's see what we get. 30 over 3 is C. In other words, 10 is C. Well, what am I going to do with that, you guys? I was hoping to find B, right?
You can reverse the Pythagorean, correct?
Perfect. So we're going to bust out that Pythagorean again, right? So it is A squared plus B squared. Put 36 in for the A squared. If C is 10, then 100 would be your C squared. Oh, I just need B squared. Okay, cool. So now that we have B squared, we can plug them in. We're done. So here's our final answer. Oops, y minus 7 over 36 minus x plus 4 over 64. There it is. So draw what you're given, stare at it, kind of think, what do I know from like that little bit they gave me? You know, and bit by bit, plug it in, okay, until you get to the final equation. All right, guys, any questions on that one? All right. Why did we use, oh, so I got the 6 because we had 1 and we had 13, and the math over here helped us find that 7 is exactly in the middle of them. And so I just did 13 minus 7 to get the 6 and 7 minus 1 to get the 6. That was me kind of checking, hey, is this number really in the middle? Well, it turns out it really was. And then that distance is the distance from the center to a vertex. So anytime you're looking at the center to a vertex, that's always going to be the letter A. Let's see, any other questions? Okay. All right, let me save this.